Okay, so we're going to go through the final of the videos. YouTube 1, we did question 2 and 6. Was forces, upthrust, P equals H rho G. And then we did YouTube 2, which was looking at question 7, which was Boyle's law. And now YouTube number 3 is looking at question 8, which is the last question in paper 1. Those of you doing physics, you'll get a second paper the following week, or after you've done this. So here it is. Question 8 is about density, and it says a scientist investigates different samples of rock. Want to calculate the density of a sample of rock, and she needs to measure the mass and the volume of the rock, because density is mass over volume. So you will not be given this equation in the exam. You need to remember what density means. So describe how to obtain accurate measurements of the mass and the volume of the rock. Well, if you remember, because a rock is an irregular shape, you can use what's called a displacement can, which has a spout going down that way, and you fill it with water till the top, and then you kind of lower in your rock, yes, which is irregular with a piece of string or whatever. Here you put a beaker, and the beaker will collect the volume that the rock displaces, and that is the volume of the rock. So for irregular solids, you need a displacement can, sometimes also called a eureka can. And then you need obviously something to measure the volume with, so you need to be able to draw or write about a measuring cylinder. So this is the equipment you need. Obviously, to measure the mass, you then need a top pan balance or a mass measure. So you imagine you put your stone on there, and it gives you the digital reading on the balance. So there's the equipment. Now your job is to get the 5 marks. So to get the 5 marks, you basically see what are they giving for the marks. So here is any 5 from the farm. So use a balance to measure the mass. There's the mass gone. Mention the displacement method like I showed you in a diagram with the displacement can. But obviously measure the mass first so the stone or rock doesn't get wet, because you want to weigh it or measure the mass while it's dry. You don't want the water adding to it for accuracy purposes. Then, so there you go, because a wet rock weighs more. So if you make that point, you could also get an extra mark. So a eureka or displacement can, so you can put that in your diagram. And you also need a measuring cylinder. So once the water is displaced, you need to measure it in a measuring cylinder so you get an accurate measure of the volume, because it's all about being accurate. That's what the question is asking for. You could also mention another accuracy, that you have to get to eye level to ensure there's no parallax in your readings. You know, a bit like the tennis judges, they sit along the line so they can make sure they have an accurate decision about whether the ball is in or out. That's called a parallax error, if you're not in alignment with the thing that you're measuring. Okay, and make sure the rock is completely submerged in the water, otherwise it will not be displacing an accurate volume. So these are so many ways to get the 5 marks, and make sure no water splashes out. So you should put it in gently. So these are all the points. Now I did this experiment with my class, so hopefully they will be able to get some of those marks. Once you get that, yeah, so that's where you got to make those 5 points, including the diagram, and you got to write it out to gain those 5 of those points. Okay, you can bullet point it. Obviously, it's like a method. You basically want to get accurate measurements. Once you do that, you then have to determine which one of these it is. So they're giving you a table shows scientists' results for rocks made from different materials. So they've got coal, marble, quartz, fluorite, hematite, and they've got the mass and the volume, and they've worked out the densities by mass divided by volume, because you know the equation. So you need to put this as a word equation, yeah, Now here they're using grams and centimeters cubed. In the previous example, we're using kilograms and meter cubed. So if we're talking about small objects, you use grams and centimeter cubed. If you're talking about larger objects, like we were doing the ship, the upthrust, we would use kilograms. So the rock X that we just used in our experiment was 32 grams and 12 centimeters. So you've got to calculate density. So that means density, which is rho, would equal m over v, yeah, which would be 32 grams divided by 12, and you work out what the volume is according to the mark scheme. 32 over 12 is 2.66, and that's grams per centimeter cubed. So that's 3 significant figures. But you'll notice in the table above that all the figures are 2 significant figures, 2 significant figures. So that would be approximately equal to 2.7 grams per centimeters cubed, and that's the value you should put there, 2.7, and the units are already done for you. So you'll get 1 mark for putting the numbers in, the correct equation, you've already got the equation, 1 for doing that, and 1 for calculating it, and tells you 2 significant figures, and this is the reason why. So according to the mark scheme, you get 1 for putting them in the equation, 1 for working it out, and 1 for giving it 2 significant figures. So if you work it out correctly, 2.6 is they'll get you 2 marks. If you don't put 3 significant figures, you will only get the 2 marks. Then rock X is made from one of the materials in the table, and you've got to say, well, 2.7 is the same as this one. All the others are not close enough. So you would say, explain which one it is. Well, it's quartz. Well, how do you get the marks? Well, you'll say you have to put the second one, once you've identified it, you have to be able to explain how did you work out that it's quartz. Well, obviously, it's the same density as quartz in a table. So look at the mark scheme again. Quartz, 1 mark, and the second mark as a density of, the mark scheme. So 1 mark for saying it's quartz and 1 mark for saying as a density of the rock is the same as the density of the quartz. So you're just matching them, okay? So I haven't put it here. Your job is to make sure you get the second mark. So you check, see the mark scheme. And then your job is to make sure in the exam you're doing everything clearly. So calculations, equation, numbers in, answer with units, rounding it up. If they tell you 2 significant figures, make sure you do so. Okay, so that's question 8. Now again, the focus seems to go every time we move the paper. Yeah, so this was question 8, and I think you would have seen the mark schemes for the other questions as well. So at the beginning of the video, it seemed to be in good focus. Yeah, so when we started, and as we go through it, the focus seems to diminish. Okay, so that's the end of this first paper that you will have done by the time you see this YouTube video, and your job when you look at it is to make sure that you have done your corrections in purple pen. If you're one of our students, purple pen is your correction color. Okay, well, thanks very much for watching. I will then also prepare answers like this for paper 2 for those of you preparing for the physics exam. In paper 2 there are also some topics which do not come in the double award, therefore that's why I've divided the topic test into those preparing for physics and those who only need to prepare for the double award, so you don't have to do exactly the same topic tests. Okay, well, give us a like to show your support, share it with your friends to make sure they're also benefiting from this, and subscribe so you know when the next video is uploaded. Bye for now.